Okay, so there's been some questions about the magician's trick. Uh, so I want to help you get an idea, especially what to do with the final step. So on the part on part C, what you're trying to do is figure out how the kinematics for the silk sheet compares to the kinematics for the glass. So we don't yet know where we want to put the glass, but we do know that the length of this sheet of the tablecloth is 1 meter. So we're going to write uh, our kinematics equation, this one, so we have x is equal to x naught plus v naught t plus 1/2 a t squared. We're going to write this 2 times. Once for the tablecloth, and then once for the glass. And we know some things about each of them. So for the tablecloth, we know that it's going to end up moving 1 meter. And we know that when the magician just starts to pull it, it has not yet moved anywhere. The other thing we know about the tablecloth is that before the magician starts pulling on the tablecloth, it's not moving yet. Okay. And then the final thing that we know about the tablecloth is that the acceleration is whatever you got in part A. Okay, so if you put these things into our kinematic equation, you can solve for time. Okay, and that would be you can get an actual specific number. And what that means is this is the amount of time it takes to pull the tablecloth completely off of the table. Now, we have a separate question of what's happening with the glass. Obviously, if we put the glass too close to the edge of the table, it's going to fall off. So what is the farthest uh, to the right that we can put the glass? Well, it's kind of the same question as how far is the glass going to move in this amount of time that it takes to get the tablecloth off the table. So we've got this equation for the glass. We do not know what x is. That's ultimately what we're really trying to solve for. We do know that the glass is not yet moving right when the magician starts pulling on the cloth. And we can set our coordinate system such that um, wherever we're starting our measurement from is where the glass is starting. And so the question is, how far does it go? So this is kind of like, what's the kind of proof in math class? You're making an assumption here that the glass is going to stay on the table. And then you're seeing how far would it move when you pull the tablecloth. And then for your assumption to be correct that the glass stays on the table, well, that distance that it moves, this value of x, you can't be closer to the edge of the table than that, right? So if we find that x is 60 centimeters, you have to be at least 60 centimeters away from the edge of the table in order to keep the glass on the table. So this is what you're going to solve. You're going to have also the acceleration from part B, and you're going to have the time from what we just solved up here. So from part C for the tablecloth. So once you put that in, you will have all of these would be known numbers, and you'll get an actual number value for x for the class, and that is your answer to the problem. Have you not been recording this whole time? You have. Good. Okay.